Hi, I am re-recording lesson 7.1 so that it records straight up and down. So in lesson 7.1, we're going to be finding inverse functions. So 2 learning targets today. 1, find the inverse of a linear or quadratic function. And 2, write an inverse function using the proper notation. 2 functions are inverse functions if and only if f of g of x equals x and g of f of x equals x for all the domain in f and g. So the example I'll go through in class, I'm going to work on the triads to show you how we can do these compositions in order to show that they are inverses of each other. And then we'll talk more about what inverses actually are. So first we're going to do in part A, it says that f of x equals 2x plus 8 and g of x equals 1/2 x minus 4. So we're going to do first f of g of x, okay, then we'll go back and do g of f of x. So to find f of g of x, we're basically going to be taking the whole g function and putting it in place of f in the spot of x. Let's go right there in place of x. So the f function is really 2 times quantity, and then that quantity will be the g function, 1/2 x minus 4, and then plus 8. So we put the g function into the f function. When we distribute 2 times 1/2 x, you just get x, and 2 times negative 4 is negative 8, plus 8, and we get just x. So we know that f of g of x is x, and we're going to hope that we also get x when we do g of f of x. So when we do g of f of x, this time we're going to take the f function, which is the 2x plus 8, and we'll put it in place of x in the g function. So the g function is 1/2 times quantity. That's where the f function will go, 2x plus 8, and then minus 4. Again, we'll distribute. Half of 2x is 1x. Half of 8 is 4, minus 4, and we get x. So because f of g of x and g of f of x both give us x, that means they are inverses of each other. So we'll do the same thing for part B. We have the x to the third, and then we have the cube root of x. So a cubic and a cube root, we're going to show they are inverses of each other. So first we're going to find f of g of x. Well, the f function is x to the third. If we put a cube root of x in there, well then the cube and the cube root cancel each other out and we just get x. And likewise, if I want to do g of f of x, I will be putting in the x cubed function into the cube root function. So the cube root of x to the third, again, a cube and a cube root cancel each other out, and we just get x. So because f of g of x is x and g of f of x is x, they are inverse functions. So that's part 1. Part 2 of our lesson is actually determining an inverse for a function. So on the next page, we have a definition here that says, function notation f inverse denotes the inverse of the function f and is read f inverse. So even though you see this superscript of -1, that's not f to the -1 power. This is actually called f inverse. Okay, so to find the inverse of a function algebraically, we interchange the x and y variables, and then we solve for y. So we have a few steps to follow. We start by letting y be in place of f of x. So wherever you see a y, you'll replace it with f of x. Then we're going to interchange the x and y, or switch x and y. Solve for y, and then replace it with notation, but this time using the inverse notation. Okay, so we are going to start with problem A. I'll do that over to the side here. So for part A, we have f of x equals -3x plus 8. We will start by swapping x and y. We'll start by letting f of x be y. We'll do that part first. Then we will switch the x and the y. So the x comes out here, and this becomes -3y plus 8. Then we have to solve for y. So I'm going to subtract 8 on both sides. We have x minus 8 equals negative 3y, and then divide both sides by negative 3. Okay. Now finally we can replace it with the F inverse notation. So F inverse of x is equal to x minus 8 over negative 3. We just found the inverse of the F function. Okay, we're going to try another one. Let's try, we'll go right below it and try part C. So in part C, we have h of x. I'm going to replace it with y. So y equals 2/3 x minus 5. Okay. Now I'm going to switch the x and y. So x equals 2/3 y minus 5. Okay. Now we need to solve it for y. So I'll add 5 to both sides. When I add 5 to both sides, I'm going to have x plus 5 equals 2/3 y. And now I need to solve it for y still, so I think I might start by multiplying everything by 3 on both sides and get rid of the fraction. So that'll make it 3x plus 15 equals 2y. Now finally divide by 2. So I have 3x plus 15 divided by 2 equals y, which I can now replace with the inverse notation, which will be 3x plus 15 divided by 2. We got room to do one more, so we'll do part D. So for part D, we have j of x, I'll replace it with y. Y equals 3x minus 2 divided by 6. So we want to switch x and y, so x equals 3y minus 2 divided by 6. Okay, multiply both sides by 6, I get 6x equals 3y minus 2. And then add 2 to both sides, so 6x plus 2 equals 3y. And finally divide by 3. So 6x plus 2 divided by 3 equals y. Or j inverse of x equals 6x plus 2 divided by 3. Okay, now these are linear functions, and linear functions aren't too complicated. They also don't have any domain restrictions. So if we had to list the domain and range for all of these functions, we would just have to write that they are going from negative infinity to positive infinity for all of them. Domain comes into play, however, when we're working with the quadratics, and so we're going to see that on the next page. Okay. So at the top of the page, we see two tables of values here. It says the domain of a function is the range of its inverse. And likewise, the range of a function is the domain of its inverse. And this can be seen in the table of values shown below. So if you see table of values, you have the top table shows that we have ordered pairs like -2, -1, and -1, -1. And now we see that they are flipped. 0, 3 became 3, 0, and 1, 5 became 5, 1. So the ordered pair xy lies on f of x, then yx lies on f inverse of x. That's going to be really handy when we start graphing, but also when we start talking about domain and range. So when finding the inverse of certain functions, such as a quadratic function, the domain may need to be restricted so both the function and its inverse are functions. Okay, so I think I went through the example C in class, but I'm going to look at the try these and try to explain how to handle these domain and range situations. So we are going to find the inverse. And then the important part of this problem is more about determining the domain and range of f of x so that they are both functions. Okay, so we're going to start by finding inverse like we did before. So when we find an inverse of a function, remember we start by letting f of x be y equals x squared minus 2. Then we switch x and y, so x equals y squared minus 2. Now we'll solve for y, so we'll add 2 to both sides. X plus 2 equals y squared. And finally, take the square root of both sides. And typically when we take the square root, we have a plus or a minus, okay, or a plus and a minus, but we're just going to keep the positives in order to allow this inverse to be a function. So we end up with f inverse of x is the positive square root of x plus 2. Okay, so finding the inverse is not a problem. But what we need to do is determine the domain and range of the function. So I want the domain and the range of the original function so that the inverse is also a function. So to do that, we really have to start with the inverse. So let's examine the domain of this inverse. We will have some restrictions because inside a radical, we can only get as small as 0. Anything less than 0, and now we have imaginary. So we need to decide, first of all, what would make a 0 in that radical, okay? And hopefully you can see that a -2 would be the smallest number x could be, okay? X has to be greater than or equal to -2 for the domain. So the domain of this function would be limited to -2 to infinity, okay? Or we could say x is greater than equal to -2. Okay? Anything less than -2 creates a negative radical, creates imaginary. Okay? Now range, however, once you plug in that -2, the smallest number that comes out will be 0. So we're going to go from 0 to infinity. So my range is y is greater than equal to 0. Okay? So now that we have the domain and range for the inverse, they'll swap for the original function, although we have to interchange the variables too. So for the domain of the original problem, we will need to restrict our domain to x, since the range for the inverse is y is greater than equal to 0, our domain we're going to restrict to x is greater than equal to 0. Okay. On the original function, there's technically no domain restrictions because you can plug anything in for x. However, to ensure that we have a function here, we are going to be restricted to choosing values that are greater than or equal to 0 here. So domain of the function is the range of the inverse, and vice versa. So now, since the domain of the inverse function was x is greater than or equal to -2, that's what our range will be. And then this is what we're looking for. Okay, so let's try it on another problem. On the next one, we have y equals x plus 3 quantity squared. Okay. Right now, there's no domain restrictions. However, we want to know what restrictions to place on the domain so that the inverse is also a function, because the inverse will have restrictions. So let's switch x and y. So x equals y plus 3 quantity squared. Now this time we have to take the square root first because we have to undo that power. So that means the square root of x equals y plus 3. Now subtract 3 and we have the square root of x minus 3 equals y. So f inverse of x is the square root of x minus 3. I want to determine the domain and range of this function, the inverse, and then go back up and swap it for my original. So the domain would be anything that would allow a real solution in that radical, which is 0. So x has to be greater than or equal to 0, or we could say from 0 to infinity. Okay. My range, well, when you plug in a 0 and get out a 0, you have to subtract 3 immediately. So that means my y is going to be greater than or equal to -3. It's going to be shifted down 3 units. So -3 to infinity. Now I swap those, and that becomes the domain and range I need to set for my original function. So my domain is going to be x greater than or equal to -3, and my range is going to be y greater than or equal to 0. So I hope that makes sense, but we will practice some more of those, of course, in class. Okay. And we'll pick some of the practice problems maybe